Now, this is one of those topics that you think is not too important, but actually it's more important than what you realise. So vectors questions in pure maths do come up quite often. If we look at the past papers, in 2023 and 2022, they came up in both paper 1 and paper 2. So both of the Edexcel pure papers, vectors questions came up. Obviously, don't forget, vectors are a massive part of mechanics. And also, if you're planning to do maths or physics or some kind of statistics course at university, vectors are really important. You're not going to avoid them. So for the purposes of A-level maths, you just need to know that vectors are arrows. And as you can see, obviously arrows can have different lengths and different directions. When you go to uni, you'll also see that functions can be vectors too, but let's not worry about that for now. Now, the notation that you use for a length of a vector, so let's take this vector here. So the length of that arrow, you'd call the magnitude of A. So you use these modular signs, and that is the length of your vector. So magnitude of B, length of B, and magnitude of C is the length of that arrow C. So let's say that we want to add two vectors. So let's look at A plus B. The idea is you're literally adding arrows together. So you're doing this arrow plus this arrow. So that there is A, then we've added on the arrow B. So we've got this to there, then there to there. So the vector A plus B is actually this red arrow there, okay? So that red arrow is the vector A plus B. And so that means the length of this red arrow is equal to the modulus of A plus B, or the magnitude of A plus B, right? That is the length of that arrow, A plus B. Now, just something that I want you to notice. Notice how if you add up the length of this arrow, okay, so magnitude of A, and then you add up the length of this arrow, magnitude of B, if you do that length plus this length, do you see how those two lengths added together are bigger than that length, right? So get a ruler, okay, measure that line, right? And then get a ruler again, measure that line plus that line. The two black lines together are bigger than the red line. So a little fact in maths is this here, right? So the magnitude of the sum of two vectors is less than or equal to the magnitude of the first vector plus the magnitude of the second. And you can just use a diagram to see that. That's quite clear from a diagram. Now, you may have noticed I put the equal sign under the inequality. So how is it possible in a situation where the magnitude of A plus B is actually equal to the magnitude of A plus the magnitude of B? Can you think of a scenario where this would all work out? Well, imagine that that was A and imagine that was B. Now add them both together. You then get something like this. So A plus B is this line from here up to here. And do you see how that length is exactly the same as the length of A plus the length of B? So what do you notice about these two vectors? They are parallel. So a little fact for you, if the magnitude of A plus the magnitude of B is equal to the magnitude of A plus B, then A and B must be parallel vectors. I've seen that before in an exam question, so do be aware of that fact. Now, what if A and B are perpendicular? So remember, perpendicular just means that the two lines make a right angle. So in other words, we have a right angle between the two vectors there. So if we join this up to create a right angle triangle, obviously that arrow there, that vector is A plus B. We've got A there, we've got B there. So hopefully you should know by now that right angle triangles satisfy something called Pythagoras' theorem. And so the length of A squared plus the length of B squared is equal to the length of A plus B squared, right? If they're perpendicular. So if two vectors are perpendicular, then Pythagoras' theorem obviously works because you know that from GCSE. Now let's say we want to subtract vectors, right? So we've got A there, we've got B there. Let's say we want to get A take away B. Well, it's exactly the same as addition. Now, something take away something is the same as that first something plus the negative of that second something. So we need to get minus B. So B is this. So that means that minus B is going to be the same arrow, but in the other direction. So this really bad arrow there is supposed to be minus B, right? So parallel to B, but the arrow is going in the other direction. So A plus minus B is going to be A, and then add on this minus B here. So something like this roughly. So minus B there. And so this vector going from here to here, sorry my arrow is really bad, that vector going from there to there is going to be A minus B. So A minus B from there to there. Multiplying two vectors, you don't worry about, that's further maths. You got something called the dot product and the cross product, but that's further maths. Dividing vectors you can't do, but you can do something called multiplying by an inverse matrix, which is again further maths, so don't worry about that. Now, if you do look at past papers, both for pure and mechanics, you'll see this term position vector or position vectors quite a lot. So let's talk about those. So the way that many of these questions work is that we're kind of traveling around an XY axis. So we're traveling around this grid here. We've got some point A, we've got some point B. I mean, to be fair, it could also be a 3D grid, like so you're traveling around in 3D. Doesn't really matter because the principle is still the same. Now, the idea is that obviously A has some coordinates. I mean, let's just pretend that's 4, let's just pretend that's 2. And let's just pretend that B is 5 across and 3 down. So a position vector for a particular point is just the vector to that particular point from the origin. So the origin, you just want to think about the origin as like the center of the universe. That is the center of the universe. And then you've got these 2 points here. So this vector is the position vector for A, and this vector is the position vector for B. So the position vector for A is 4i plus 2j. Okay, so remember I is in the x direction, 4i, and then plus 2j. And then the position for B is going to be 5i, take away 3j. So we have that there. Now let's say you want to work out the vector A to B, so this vector going from A to B. Now this is kind of similar to what you would have seen back at GCSE, where you kind of do like these routes, right? So you got this diagram and you're like traveling along different routes along the diagram. So to go from A to B, notice that we could go from A to O, so from A to the origin, and then we can go from the origin to B, right? So the vector A to B is the same as A to the origin and then the origin to B. Now we know that the origin to A is the position vector of A, and we called that A. So A to O is the opposite of that vector. It's the negative of that vector because we're going in the other direction. So that vector is negative A. Now O to B, that is literally the position vector of B. So we just add on B, so plus B. So what I want you to see is that the vector A to B is the position of B, take away the position of A. So you can use this fact in any question you like. So the vector A to B is the position of B, take away position of the first letter A. Now I do want to talk about parallel vectors again just briefly. Now obviously all these vectors here are parallel, right? Even though this arrow is going in the other direction to these two, they're still parallel, right? So let's just call this first one A, we'll call this third one here B. So if vectors A and B are parallel, it means that you have to multiply one of these vectors by a fixed scalar number in order to achieve the other one. So you can say that A is equal to lambda, some kind of constant. You usually use the Greek letter lambda in these questions. So this constant times by B. It could be the other way around too, so you could write it as B equals lambda times A. It doesn't really matter. That lambda is just a constant, and it will be different depending on which way round you have it. So to look at a bit of a messy example, let's say we've got the x-y axis, so the x-axis here, y-axis here. We've got point A, point B, point C. So let's say this vector C, so from the origin to C, this vector C, let's say it's parallel to 10i plus j, so 10 across, 1 up. Let's say it's parallel to that. So what you can say for fact is that this vector C must be equal to some multiple, some lambda value, times by this direction, 10i plus j, where lambda is some real value to be determined. So in a tricky exam question, what you could do to try and work out this lambda is you could say, okay, well, to go from O to C, I could take this route. So I could go from the origin to B, and then I could go from B to capital C. So if I do this O to B plus this B to C, I end up with that vector C. Do you see how that makes sense, right? So this arrow plus this arrow gives me the C arrow, okay? So in an exam, you could say that that vector C is equal to O to B and then plus B to C. Now we know that O to B is this lowercase b, B to C, I mean, they probably give you that in the question in the exam, so you'll probably have this B to C. And so what you can then say is that this vector plus this one must be the same as what we said up here, right? So this multiple of this 10i plus j, because again, the vector must be parallel to 10i plus j. So I'm just going to pretend that the vector B, this vector B is 6i take away 2j. I'm going to pretend that this B to C is ki, some missing value k, plus 3j. So far we have something like this. So in the I direction, we got 6 plus k in the I direction. And then in the j direction, we got minus 2 plus 3. So we just have 1 in the j direction. Now the key thing to notice with this question, notice how the I component is 10 times bigger than the j component, right? 10i, 1j, right? Even with the lambda there, I mean, it doesn't matter what that lambda is. It could be 10, 100, minus 5. That number is always going to be bigger than this number in front of the j, 10 times. So if that vector is equal to this vector, then it means that this number must be 10 times bigger than this number because they're exactly the same vector. So now you can say that this 6 plus k is 10 times bigger than this 1. And then you can get that k is 4. That's kind of the style of exam question that you see sometimes. And just one more thing to mention, if you do see angles in vectors questions, it means you got to use the sine and cosine rule, basically. I mean, if you know the dot product in further maths, you could do that too. I do have a free revision guide that I made on vectors. Just go to my bio, click the link, you'll be able to access it.